The next element is gas. What is gas? Gas is a state of matter which has no definite volume and has no definite shape. It is composed of very tiny particles called molecules at constant random motion. Gas, when the liquid is exposed to heat, it produces gaseous state, which is the vapor. You cannot tell the definite volume not unless it is confined to into a container, but never the shape. A question: is there a possibility to determine its volume? Is there a possibility? Only when like I said a while back, only when it is confined to a container. That's the time you can determine its volume, but never you cannot tell its shape. There are classification of gases. First, the natural gas. The gas used to heat buildings. It is also used for cooking and provides energy for industries. A good example are butane and propane. Okay, some of you already using the butane, isn't it? Nabibili ka dun sa 7-Eleven, which make up a small proportion of natural gas. Become liquids when placed under the large amount of pressure. It appears that, di ba, you will shake the butane, which is contained on a container. It appears that it's just like, it feels like a liquid. But once you open the container, it appears no nothing is inside because the vapor cannot be seen by our naked eye. So that is how the natural gas uh, will appear, or no, will natural gas when it is in the um, container. Next is the manufactured gas. Manufactured, it goes to the process. This gas, like synthetic liquid fuels, is used chiefly where certain fuels are abundant and others are scarce. I have already told you what is meant by synthetic. A synthetic liquid fuels that go to a process. A good example is coal, petroleum, and biomass that, that can be converted to gas through heating and various chemical procedures. So when there are objects that can produce a gaseous state when exposed to heat and additional of chemicals as part of the procedures, since this goes to a procedures and processes, these are considered manufactured gas. According to physical properties, meron tayong compressed gas. Gas in which at all normal temperature inside its container. However, temperature affects the volume and pressure of the gas. Okay? Compressed gas is also known as non-liquefied gas. Okay? Again, compressed gas is also known as non-liquefied gases. It is pressurized or permanent gases. These gases do not become liquid when they are compressed at normal temperatures. Even at a very high pressures, this cannot, the gases do not become liquid. Common examples of this are oxygen, nitrogen, helium, and even argon. Okay? So, sabi nga dito, however temperature affects the volume and pressure of gases. when these are uh, at normal temperature inside its container. Nakakompress siya. Okay? When they are placed in a container, however, there is something happen, or the temperature may vary depending, or the pressure may vary depending its temperature. That is why some are that are contained or stored in a container should not be placed or must not be placed in a hot area. Next is the liquefied gas. The gas which at normal temperature inside its container exists partly in a liquid state and partly in gaseous state in other pressure as long as any liquid remains in the container. A liquefied gas exhibits a more complicated behavior as the result of heating. The pressure basically depends on the temperature of the liquid, although the amount of liquid also affects the temperature under some condition. A good example is the lighter. The lighter, di ba? It appears na liquid siya, okay? But when you try to take off the cover of the lighter, the liquid form that we see becomes, or it will disappear, or it will vanish. Okay? It will vanish. Yan yung liquefied gas. It appears that it is a liquid, yet it is a liquid inside. But once already moves out from its container, becomes already dry because the gaseous state, or the vape, or the gas inside rises up and dissipated, mixed with air and dissipated. This is the cryogenic gas, a liquefied gas which exists in a container at temperature far below normal atmospheric temperature, usually slightly above its boiling point and correspondingly low to moderate pressure. It is also a liquid. However, it has a low to moderate pressure, or far below to normal atmospheric temperature. A good example of this gas are air, carbon monoxide, ethylene, fluorine, helium, hydrogen, methane, nitrogen, and as well as oxygen. Another example, explanation of cryogenic liquids. These are liquefied gases that are kept in the liquid state at a very low temperature only. So the word cryogenic means producing or related to low temperatures, and all cryogenic liquids are extremely cold. Have you seen already? Let's say for example yung babango, have you feel it na malamig? Di ba? Malamig yung parang dun sa loob. Okay? Or you can feel the container that is cold. Okay? Because these are intended na nakalagay talaga sa cold area. It should not be placed at on a hot area. So these gases must be cooled below room temperature before an increase in pressure can liquefy them. Kaya nga, it was the temperature far below to normal atmospheric temperature. So I want you to take a look on your notes that based on the usage, first is the fuel for burning with air to produce heat and utilized as power, light, and sources. Diba? Ganyan naman talaga ang gamit ng fuel. And for another usage is the for industrial use in industrial processes such as those used in welding and cutting of metals using the oxygen or acetylene, refrigeration, chemical processing, water treatment, and so on and so forth. Makikita niyo sa notes nyo. Another is the medical. It is for treatment such as for anesthesia and for respiratory therapy. A good example is the chloroform, nitrous oxide, or oxygen. Medyo technical na yun na mga terms. And based on chemical properties, the reactive gases, any gases that reacts within itself. So it is the reaction that will take place when gases mix with particles and toxic gases, any gases that may complicate firefighting efforts due to its serious life hazards. Because these toxic gases, at any time, it may explode, especially when one chemical is mixed with another chemical, it may cause explosion. Okay? Or it may also cause a uh, something smoke that may irritate or may cause danger to a person. And flammable gases, any gas that which burn in normal concentration of oxygen in the air. Okay, sinagot na natin yan. While we have already explained that. And non-flammable gases, any gases that which does not burn in air. Those that do not support combustion, which is called the inert gas. Again, any gases that which does not burn in air, those do not support combustion. Like for example, yung ating the composition of air. That air comprised of 21% of oxygen, 78% of nitrogen, and 1% of inert gas. Kasi kapag sumasabog, it will explode. Maybe all of us will die. Because the 1% inert gas is mixed already with the other components such as the oxygen as well as the nitrogen. So you can see the example of the flammable gases. Makikita nyo sa inyong notes, the natural gas, the most common flammable gas. Methane, the lighter than air and not toxic. Propane and butane, colorless, tasteless, odorless, and not toxic, heavier than air. Then acetylene, colorless, tasteless, odorless, shock sensitive. Hydrogen, difficult to contain in a container, lighter than air, extremely flammable. Next is ethylene oxide gas at room temperature, extremely wide explosive range, and oxidizer that can burn inside its own container. Then example of non-flammable, oxygen, ammonia, refrigerants, halogens, acid gases, inert gases, other gases. So we will not talk deeper onto that because it may difficult for us to determine when in terms of this requires technical explanation. Then we have also the hazards of gases, combustions, explosion is among the dangers related to gases. First is the liquid phases of a flammable gas or liquefied flammable gas is released from its container, piping, or equipment. The second one is the gas mixes with air. Okay, because there is possibility that gas mix with air. Okay. The third one, when certain proportion of gas in air, the mixture is ignitable and will burn. And the fourth one, when ignited, the flammable mixture burns rapidly and produces heat at a fast rate. And the next is the heat of absorb. If the heat is absorbed by anything within the vicinity of the flame, and if the heated air is not free to expand because it is confined, pressure in the container will increase. Well, of course, when let's say for example, nagkakaguluhan yung mga grupo na tao, eh nailagay sila sa kulungan, there is a possibility na nagkakainitan na doon, possibly na magbugbugan, magkakainitan, so the pressure is also increasing. Same goes also na yung when a hot water is placed on a area which the temperature is keep on increasing, there is a possibility that the temperature of the boiled water will also increase. And if container is not strong enough to withstand pressure, some parts of the container will suddenly depart or break, thus resulting to violent release of the pressure accompanied by a loud sound known as explosion. Okay? So, yung mangyayari kasi, let's say for example, yung bote, dinagyan mo kaagad ng mainit na tubig. What will happen? The bottle cannot withstand, thus the bottle will be broken because it cannot stand with the temperature. Kaya mostly ang ginagawa natin muna, cold water, then mix mo yung hot water, then magiging warm na siya. Medyo doon mo ilagay tapos ilagay mo sa bote para sa ganun, yung init ay medyo na-absorb ng bote bago ilagay yung mainit na tubig. Pagkakalagay mo talaga kaagad ng mainit na tubig sa bote, without warming up yung bottle, talagang sasabog yun. Kaya accompanied by loud sound, ang tawag natin doon ay explosion. Since the source of the pressure is combustion, this kind of explosion is known as vapor air release. Okay. What is the distinction between explosion from detonation? Explosion is a violent effect of a chemical reaction when combustion process is confined so that appreciable pressure occurs. While detonation, violent reaction beginning with a very simple ignition that initiates as chain reactions. A good example lang naman dito, para makuha natin kung anong pinagkaiba nitong dalawa. Detonation is a type of explosion. Both detonation and explosion occur when the volume increases rapidly and there is a high release of energy. So detonation is more intense as it produces supersonic, that includes shock waves, whereas explosion has less intensely and produces low intensity of shock waves. Katulad lamang ng mga pagsabog, nung una sumabog, you have heard the loud noise and then another followed by more louder sound. First sound or first effect is not fatal, but the second wave of the explosion is more fatal than the first one. Now, what is the distinction between compressibility, expandability, permeability, and diffusion? What is the distinction between these three? Compressibility, when the gases are placed on a container. Ay yung sinasabi natin compressed gas. When it is placed in a container. Okay? Now, we have also the permeability. This happens when there is a opening, when there is an opening of the container, it starts to expand. Okay? But expand and try to what do we call? Try to penetrate those small holes. As we mentioned, gaseous, those atoms and molecules are breaking away and dividing into many. Okay, so that is permeability. When the gas is already expanded from the container, it moves out, and then moves out, it goes around the house, for example, that is already expandability kasi pag ganyan yung takbo, ng gas. And anything na makita doon na pwedeng pasukan that can penetrate, that is permeability. And when we say diffusion, there is already intermingling of molecules, division of the molecules into many, multiplication of numbers of molecules. Thus, there is already propagation, or the gaseous state is already, or the gas will already scattered, will be scattered in the house, for example. Again, compressibility when it is still inside the container. And once na nakalabas sa container, that is already, and moving out around the area, that is already expandability. And when this gases is going on side or moving out on anything that the what do you call, anything that can pass through, that is permeability and diffusion, then they are already multiplied into many. Next is the chemical fuels. It is produced in a solid and liquid form, create great amounts of heat and as well as power. It is used chiefly in rocket engines, and chemical rocket propellants consist of both a fuel and an oxidizer. What is common rocket fuel? And so the oxidizer is a substance such as nitrogen tetroxide that contains oxygen. When the propellant is ignited, the oxidizer provides the oxygen the fuel needs to burn. Again, when the propellant is ignited, the oxidizer provides the oxygen the fuel needs to burn. Next is the nuclear fuels. Provide energy through the fission or fusion of the atoms. We have already explained the distinction between fission and fusion. While the fission, it can be controlled, thus it is appropriate to provide um, energy. It is applicable to to generate power because it can be controlled. Unlike fusion, it is not. So they also power some submarine in ships. Nuclear fuels are used mainly to generate electricity. What is the most fuel that provides nuclear energy? What is the most fuel that provides nuclear energy? It is the uranium. When the atoms of these elements undergo fission, they release tremendous amounts of heat. Tremendous amount of heat. Again, when the atoms of these elements undergo fission, they release tremendous amounts of heat.